Even though lots of maps help us understand our geographical space, there's one map that some geographers would say is the most important to understand all life on Earth: the map of the world's precipitation. We can think of precipitation as the final flourish in the hydrological cycle that circulates water molecules between the four Earth systems. It's all the rain, snow, sleet, hail, or any liquid or solid that falls from clouds in the atmosphere. And we need water for so many parts of our lives: agriculture, industry, transportation, recreation, and not least for all the flora and fauna that live here. Water is the universal solvent, which means it can dissolve more substances than any other liquid, and we almost never find completely pure water. That's pretty important because as water moves through the water cycle, it transports both vital nutrients and harmful pollutants across spaces and places. So using a map of precipitation helps us track water on Earth and reveals potential consequences of differing access to water. Like if we compare our precipitation map with a map of population distribution, we can understand a simple but powerful pattern of human geography. Where there is water, there are people. But it gets a little more complicated than that, because where there are people and limited resources, there's often conflict and bigger geographical questions at stake. I'm Alize Carrere, and this is Crash Course Geography. We started our journey into physical geography by looking at the big picture to reveal the geographic patterns and processes that create Earth's environments and support all living things. And we learned that the spheroid shape, rotation, revolution, and tilt of the Earth cause insolation, air temperature, pressure, and wind to form worldwide patterns that strongly depend on latitude. Ultimately, precipitation comes from clouds in the atmosphere, which are complex structures that change based on many of those patterns. So precipitation varies a lot between different places, especially different latitudes. Looking at our map, there are areas with a lot of precipitation, like the island we call Borneo. The air here near the equator is hotter and has a higher dew point, the temperature when the air is saturated with water vapor and condensation is imminent. But areas like what we call the Svalbard Islands in the Arctic Ocean get very little precipitation because the air at those latitudes is cold and dry. A different kind of precipitation variability can happen within a place that spans similar latitudes. Like there's a region that makes up a large chunk of the continental interior of the US and Canada, often called the Great Plains or the Prairies. Because the Great Plains sit deep within the interior, far from oceans, a phenomenon called the continental effect causes huge temperature fluctuations with scorching summers and frigid winters. In addition, the Rocky Mountains, which are west of the Great Plains, form a barrier to the warm, moist winds blowing in from the Pacific. Basically, as the winds hit the side of the mountains, the air is forced to rise. As it rises, the air expands and cools enough that water vapor molecules can condense to form clouds and precipitation. The resulting rain or snow or fog or whatever is called orographic precipitation, which got its name from oros, a Greek word for mountain. Then, as the air descends the other side of the mountains, it gets warmer as the air molecules are compressed together and any leftover water droplets evaporate. So we say the side of the mountains not facing the winds, like where the Great Plains are, is in a warm, dry area called the rain shadow of the Rocky Mountains. Orographic precipitation patterns can be found on mountains worldwide. In Argentina, the Patagonia Desert lies in the rain shadow of the Andes Mountains, while the Trans-Himalayan region of Tibet and Central Asia lies in the rain shadow of the Himalaya Mountains. The Great Plains straddle the 98th meridian. So there's precipitation sometimes. It's just unpredictable. The result is a steppe or semi-arid climate which is too dry to support forest, but too moist to be a desert. The dryness can be linked to some combination of the continental effect, the rain shadow location, and subtropical high-pressure systems in the atmosphere. The unpredictability comes from local conditions and the constantly flowing atmospheric and ocean circulation. So basically, rainfall amounts can change dramatically from one year or season or month to the next. A year with lots of rain could be followed by several years of below average precipitation. So drought can be a major recurring problem for people, animals, and plants. In fact, at one point, the Great Plains was called the Great American Desert, even though it's technically a stretch of grasslands between forests to the east and deserts to the west. By thinking about the physical space, we learn more about how our understanding of the perceived space has changed. It wasn't until the inventions of barbed wire, the steel plow, well drilling techniques, and the railroad solved the region's unique spatial problems that it became a place where European people settled. Over long periods of time, grasslands produce excellent soils, making them extremely productive farmlands, but also prone to severe soil erosion from overfarming and overgrazing. So the combination of mass settling and farming, unpredictable precipitation, and high temperatures led to devastation in this physical space. One of the most significant droughts in the last century was the Dust Bowl, which ravaged the Great Plains for nearly a decade from 1930 until the fall of 1939, when the rains finally came. So now our idea of the Great Plains as a place is forever tied to hardship and even lack of opportunity, not just precipitation patterns like the rainfall effect, all because of the physical geography of the space layered with the human geography of our lived experiences there. On the other side of the Rockies and east of the Sierra Nevadas, there are also vast stretches of semi-arid regions, with some true deserts in the southwest. Like in the Great Plains, precipitation is rather unevenly distributed, so the Colorado River is actually the region's largest water source, dubbed the lifeline of the Southwest. Actually, 90% of the surface water in the Colorado River comes from snow in the Rocky Mountains, which melts, flows down a network of smaller tributary streams, and reaches the main river. The challenges of relying on water from one source like a river, instead of from widespread rainfall, involve both who needs the water and where they are relative to the source. Managing water resources is a spatial problem. For example, the biggest water users are farms, factories, and towns, but they aren't all on the riverbanks, so they have to find ways to transport the water they need. And those that live near the upstream parts of the Colorado River can use a ton of water if unregulated, leaving less for anyone who lives downstream. And the Colorado River is, well, a river. So as it winds from its source to its mouth, it's unaware of any political boundaries, like those from counties, Native American tribal land, or even international boundaries. But the humans that have made this semi-arid region their home generally use all these political boundaries for decision-making about water. Understanding why precipitation is unevenly distributed, how drought can change seasonally, and how people use water are key parts of geography. And the intersection between these physical geography processes and human geography decision-making can be the source of a lot of tension, especially when it comes to environmental policies. For example, Native Americans have used the Colorado River's water and managed its resources for thousands of years. But the modern legal doctrine that governs water rights in the West, which goes back to the gold rush of the 1840s and 50s in some places, is the prior appropriation doctrine. This doctrine allocates rights based on who started using the water first, except traditional Native American claims. Then in 1922, the 7 states of the Colorado River Basin drew up the Colorado River Compact on how to divide the waters, because seasonal precipitation alone wouldn't provide enough water for everyone that lived there. But they overestimated the flow of the river and didn't account for how the amount of water varies year to year. So each state was allocated more water than actually exists, a problem that's led to intense legal battles between states. Like California is a downstream user, but also a very powerful state, and for decades was using more water than it was allocated. So in 2003, after threats that their water would be cut off, California agreed to reduce its use of the Colorado River water over the next 14 years to allow upstream states their share. The other big problem was that the river's natural flow had to be physically moved to suit certain human wants and needs, which made things even less fair. Like 2 huge dams, the Hoover Dam on the Arizona-Nevada border and the Glen Canyon Dam in Arizona, were built in the 1930s and 60s to store and hold back water in reservoirs. Lake Mead, the reservoir for the Hoover Dam, supplies water to 25 million people in California, Arizona, and Nevada, and generates hydroelectricity for the region. But all that water still has to be divided between different needs. And since the 1950s, explosive urban growth in upstream states, like the growth of cities like Phoenix and Las Vegas, meant skyrocketing demand for water there, and as a consequence, less water for farmers and other rural communities. Basically, early miscalculations and mismanagement has created a water crisis that affects 40 million people and 5.5 million acres of farmland. As of 2021, privatizing water rights is being proposed as a new solution. Private investors would buy water rights, and cities, states, and individual farms could buy water from them, even across state lines. This way, the market would decide whether water was more valuable serving urban or rural populations, redefining the century-old rules for sharing the river. So yes, this would turn the river water into a commodity that could be bought and sold. Private investors would redraw the map of water distribution in the West and make a profit. But while water management enters a new phase with big players from Wall Street staking a claim, Native American tribes are still working to obtain their water rights that they were finally awarded in 1908. There is no substitute for water. Today, we mainly focused on one region with one kind of precipitation pattern, but we still saw how studying precipitation opens up lots of deeper questions about geography, from what makes a region habitable to political struggles over resources. Some of the most serious geopolitical issues in the Middle East, North Africa, South Asia, and the Western US relate to control over water. Like water shortages affect public health, reduce agricultural productivity, and damage ecological systems on which we depend. So really, that map of Earth's precipitation and where and how much water falls from the sky is the foundation of a bunch of big geographical questions. Who should control water? Is water a basic human right? And how have humans altered the environment to get the water we need? And at what cost? As geographers, we'll keep looking for new answers in the stories and patterns of the Earth. Like next time, when we'll look at cyclonic systems that bring dramatic weather and spatial implications affecting human activities, like where we build our homes and choose to live. Many maps and borders represent modern geopolitical divisions that have often been decided without the consultation, permission, or recognition of the land's original inhabitants. Many geographical place names also don't reflect the indigenous or aboriginal people's languages. So we at Crash Course want to acknowledge these people's traditional and ongoing relationship with that land and all the physical and human geographical elements of it. We encourage you to learn more about the history of the place you call home through resources like nativeland.ca and by engaging with your local Indigenous and Aboriginal nations through the websites and resources they provide.